So today we are going to see the effect of source inductance or effect of source impedance on converters. The source impedance will cause some adverse effects in the output voltage and output current of the converters. So the source impedance, in the sense the transformer will have some resistance and leakage impedance, so that may be considered as source impedance, and the leakage reactance will be considered as the source inductance of the source inductance. So let us see what are all the adverse effects of that source inductance, and due to which what is the changes that will be made in the output voltage and currents. So the effect of source impedance is, if the source impedance is purely a resistance, that is Rs, that is the source will have only the resistance, means then the output voltage will get reduced, the net output voltage will be reduced. And if the source inductance is an inductance alone, if the source impedance is an inductance alone, it will causes some distortions in the output waveform, and it will causes the incoming and outgoing ACRs to conduct together. Incoming and outgoing ACRs means, for positive half cycle, two thyristors in a single phase full bridge rectifiers, two ACRs will be conducting, and remaining two ACRs will be responsible for the negative half cycle. So for the negative half cycle, the positive already conducting positive half cycle thyristors are the outgoing thyristors, and the ACRs to be conducted for the negative half cycle will be the incoming ACRs. So that will cause some time delay for the turning off, that is the computation, and the turning on the ACRs. So that is called completion overlap period. So the at the time at which the incoming and outgoing ACRs both will conduct is called the completion period or overlap period, and the angle for which all the ACRs are conducting is called the overlap angle mu. And the V naught is the average output, average value of the conducting phase voltages, means in single phase converters the V naught will be equal to 0 for the overlap period, and in addition to that the output current waveforms will be distorted. So these are the effects of the source impedance. So the net output voltage will be reduced, and it will cause distortions in the output current waveforms. And this is the single phase full bridge converter with the source inductance LS, and this is the source inductance LS. So this LS, here we are neglecting the the effect of source resistance RS. So we are considering only the inductance effect LS, and we are having the four thyristors T1, T2, and T3 and T4. T1 and T2 will be conducting for positive half cycle, and T3 and T4 will be conducting for negative half cycle. And this is the load. We are having RL load. So the load will be having the resistance and the inductance. So this circuit can be drawn as equivalent circuit like this. So this is the Thevenin's equivalent circuit. So here we are having the input voltage source. So for positive, the conducting, that is the how the conducting path or how the current will flow means. So for positive half cycle, the Vs1 will be positive over here, and the two terminal will be negative over here. So the current will flow like this. The T1 will be conducting, and through the load it will return to T2 and to the second terminal. So this will be the current flow path. So according to that, we can say that plus 2 LS, the current will flow, plus 2 LS and LS2 T1 and T12 RL, that is load, and RL load to T2 and T22 negative terminal of the source. So this will be the positive terminal of the source, and this will be the negative terminal of the source. So this is for positive half cycle, and similarly for the negative half cycle of the input voltage. So the conduction will be, you can change it in another color. So the conduction here, it will be positive, and here it will be negative. So the current will flows from the second to T3, then to the load RL, and it will return through the T4 to the negative terminal of the input source. So here also it will be in downward direction. So here also the 12 flows from the positive terminal and positive to T3, T3 to load, that is RL load, and RL load to, again it is flowing through T4 and T4 to, it is going to the negative terminal of the source. So this will be the current direction of the positive half cycle, and this will be the current direction of negative half cycle. So positive half cycle, from this we can draw the equivalent circuit. So here plus 2 LS to T1 T2. So this will be combined, T1 and T2 will be combined since it is a series current flow. So T1 T2 will be combined and it is flowing through the load and it will return to the minus. And same as that for the negative half cycle, it is flows from positive, then all are in series, that is plus to T3 RLO T4. So this will be combined, and here also after T4 there will be some LS. So LS, so after it will reaches the minus. So here also it will include the source inductance and T3 and T4. So here the first one, for the first case the current will flows like this. So here the first current for the positive half cycle, the current will flows in the outer loop. So this will be the current flow direction. And similarly for the negative half cycle, we will have the current direction like this. So this will be the current direction. So for the negative half cycle, so this will be the current direction. So this is the same as that of the equivalent circuit and for the single phase full bridge converter. So from this circuit we can draw some equations, and this is the waveform. So first one will be the source voltage. So this solid line will be the source voltage, and the output and it is segregated as, for positive half cycle it is called as V1, and the inverse of the voltage will be V2, that is it is mentioned for the negative half cycle, and this will be the V0. So V0, the triggering the conducting thyristors are T1 and T2. So the thyristors are triggered at alpha, right? So, but it will take some time. The current in the thyristors T1 and T2 will take some time to increase from 0 to the maximum value. So, this is the 0 value of output current that will increase to the maximum value of I0. So, this will be the maximum current. So, that is I0. So, that will take some time to reach the maximum value of current. And before the positive half cycle, the thyristors conducting are, suppose here the conducting thyristors are T3 and T4. So that has to be turned off. So the already conducting thyristors will reduce from the maximum value of current to 0 in the same period of time. So in this period, that is the incoming thyristors, that is T1 and T2, will increase from 0 to maximum, and the outgoing thyristors are turning off, so that the current is reducing from maximum value of I0 to 0. So in this short period, all the four devices of the converters are conducting. So here all the devices T1, T2, T3 and T4 are conducting. And after this, the already outgoing pairs T3 and T4 are, since the outgoing pairs are T3 and T4 before the positive half cycle, so this will be completely turned off. And after this, from alpha plus mu, so this is alpha, and this short period is called as the commutation angle, that is mu. So this point will be alpha plus mu. So for alpha plus mu, this is the alpha plus mu, that is the computation overlap angle is mu. So alpha plus mu to pi, the devices which will be conducting are T1 and T2, and that will be lasting up to. So this is the case, that is this point will be the pi plus alpha. So pi plus alpha, since it is an RL load, so here it will be pi. So up to pi plus alpha. So this is the pi plus alpha. Up to pi plus alpha, the T1 and T2 are conducting. So this is pi and this is pi plus alpha. So up to pi plus alpha, T1 and T2 are conducting. So up to this, that will have the maximum current. That current will be flows through the thyristors T1 and T2. So at this point, the T1, T2 has to be turned off. and next pair of thyristors T3 and T4 has to be turned on. So this current has to be reduced to 0, and the next incoming thyristors are T3 and T4 that will increase from 0 to maximum. So again the overlap period will exist, that is mu. So in this period also the 4 SCRs T1 to T4 are conducting. So after this overlap period, the next current will flow through the T3 and T4. So this will be repeating for the next cycle also. Here also T3 will decreases to 0, and T1, the current through T1 T2 will increases from 0 to maximum value of current. And during this overlap period, due to all the devices are conducting, the voltage across the output will be 0. So during this overlap period, the voltage across the load will be 0 since the 4 devices are conducting. So during the mu period, the output voltage is 0. So here also the output voltage is 0. And this is the distortion in the output voltage waveform, and the current also will have the exponential increase and exponential decrease, so that there will be some delay period in the conduction and the turn off time. So from this equivalent circuit, we can write the equations for the first, that is for the first branch. So this branch, that is A to B. So we can write. So this is the voltage source, and V1 V1 minus, that is drop, that is Ls into the current flowing through this inductance is I1. So Ls into di1 by dt, and the next branch will be this branch, that is a DC. For this we can write the expression using Kirchhoff's voltage law, that is V2 is equal to V2 minus Ls into di2 by dt. So I1 is the current flowing through the thyristors I1 and I2, and I2 is the current flowing through the thyristors T3 and T4. So V1 indicates the Vs will have the magnitude, that is same magnitude. So that will be positive for V1 and negative for V2. So this is the expression. Both the voltages are in parallel, so that both will be equal. And by rearranging these expressions, V1 minus V2 is equal to Ls into di1 by dt minus di2 by dt. So if V1, that is Vs, is sinusoidal input voltage source, that is V1 sine omega t. So V1 can be written as Vm sine omega t, and V2 is the negative half cycle voltage, that is in negative magnitude, that is V2 is can be written as minus Vm sin omega t. So so V1 minus V2 can be Vm sin omega t minus of minus Vm sin omega t. So totally 2 Vm sin omega t. So Ls into di1 by dt minus di2 by dt is equal to 2 Vm sin omega t. So as the load current is assumed constant throughout, I1 plus I2 is equal to I0. So that di1, that is I1 plus I2 is equal to I0. So on differentiating this with respect to dt, di1 by dt plus di2 by dt is equal to 0, since I0 is a constant. So this can be written as, so by rearranging, and this can be written as di1 by dt is equal to di1 by dt equal to minus dit by dt, di2 by dt. So here we can write minus di2 by dt is equal to minus di1 by dt. So this term can be written as minus di1 by dt. So di1 by dt. So di1 by dt plus minus of minus plus di1 by dt, that will be equal to 2 di1 by dt. So this will be 2 into di1 by dt, that is equal to 2 into Vm by Ls sin omega t. Sin omega t. So these two will get cancelled, so that we will get di1 by dt is equal to Vm by Ls sin omega t. So the load current I1 through the resistor pair T1 and T2 builds up from 0 to I0 during the overlap period mu, that is at omega is equal to alpha. So I1 equal to 0 at I1 equal to 0, and omega t is equal to alpha plus mu, I1 equal to I0. So here from this waveform we can see when omega t is equal to alpha, I naught is 0, that is I1 will be equal to, this is your I1, and I1 will be equal to 0 when alpha, and when alpha plus mu, it will reaches the maximum value of I naught. So the limit will be alpha to alpha plus mu. So at alpha, the I1 equal to 0, and at omega t equal to alpha plus mu, I1 equal to I naught. So on integrating this on both sides, so this dt will goes to the right hand side, and integrating on both sides 0 to I naught, and the limit will be alpha to alpha plus mu. So here we are integrating with respect to dt. So omega t is equal to alpha. So the t will be equal to alpha by omega. So this will be your lower limit, and alpha plus mu equal to omega t. So from this also the t can be written as alpha plus mu divided by omega. So here the upper limit is alpha plus mu divided by omega. So on integrating this, the constant terms, this will be I naught and Vm by Ls, and the sin omega t on integrating this with respect to dt. So that will be minus cos omega t divided by omega, since we are integrating with respect to t. So it will be minus cos omega t divided by omega. So omega can be taken outside, and the upper limit is minus cos alpha plus mu. So here we are, instead of t we have to substitute as minus cos omega into alpha plus mu by omega, minus the lower limit is cos, minus into minus plus cos omega into alpha by omega. So in both the cases, omega will get cancelled. So we'll get the expression as Vm by omega Ls into cos alpha minus cos alpha plus mu. So next, then output, our average output voltage can be derived as, that is V naught is equal to Vm by pi. That is for a single half cycle we are deriving Vm sin omega t, and now the limit is, for every case we will substitute, that is alpha plus mu, that is alpha to pi. So here we are substituting it as alpha plus mu to pi plus alpha. So here the mu will be the additional case. So in all the cases, we will substitute the limit as alpha to pi plus alpha. So due to this, the computation, that is conduction angle is delayed by mu. So alpha plus mu to pi plus alpha into sin omega t d omega t, and on integrating sin omega t, we will get minus cos omega t. So cos omega t, and substituting the upper limits, minus cos alpha plus pi minus of minus plus cos alpha plus mu, so that we will get as cos alpha plus mu minus cos alpha plus pi. So cos alpha plus pi will be cos, that is minus cos alpha. So minus into minus plus, that is cos alpha plus mu. So cos alpha, from this, this is your V naught. So from the previous expression, that is a current expression, from this we can write two terms, that is cos, for cos alpha we can write the term, and cos alpha plus mu we can write another term. So cos alpha plus mu is equal to cos alpha minus omega ls into I naught by Vm. So on substituting this cos alpha plus mu in this V naught expression, we will get the V naught as 2Vm by pi cos alpha minus omega ls by minus omega ls by pi into I naught. Similarly, from the I naught expression, we can derive the cos alpha. So this cos, on substituting this cos alpha in this expression, we will get V naught is equal to 2Vm by pi cos alpha plus mu plus omega ls by pi into I naught. So this is from the expression we can derive this equivalent circuit. So this equivalent circuit is V naught is equal to 2Vm by pi cos alpha minus omega ls into I naught. So this is the voltage source, and this is the drop in the inductance, source inductance. So the voltage source is, normally we will get the for RL load, for full bridge rectifier, we will get the VDC or V naught is equal to, that is V naught, that is average output voltage will be equal to 2 Vm by pi cos alpha. So that is for 2 Vm by pi cos alpha. So that is for full bridge rectifier without source inductance. Now it is reduced by a factor of minus omega ls by pi into I naught. So this will be considered as source. Minus omega ls by pi is considered as a drop, and the current through this will be I naught, and this diode indicates the unidirectional flow of current. So that will be your V naught. So V naught is equal to 2 Vm by pi minus omega ls into by pi into I naught. So that will be the equivalent circuit. And this is the graph drawn between the V naught and I naught. And when I naught is equal to 0, V naught will have the maximum value from this expression. And when I naught is equal to 0, so the V naught will be equal to 2 Vm by pi cos alpha. So this is the point there where I naught is equal to 0. So this is the current at I naught is equal to 0 and mu is equal to 0. And from the current expression, when V naught is equal to 0, so the current will be maximum. So here we have to substitute the mu pi is equal to, that is mu is equal to pi and V naught equal to 0. On substituting this, when mu is equal to pi, that is cos alpha plus pi, that will be minus into minus plus cos alpha, that is minus cos alpha. Pi plus alpha will be minus cos alpha, so minus into minus plus cos alpha. So here we will get my plus cos alpha on substituting mu is equal to pi. So cos alpha plus cos alpha 2 cos alpha. So 2 Vm by omega ls into cos alpha. So that will be the maximum value of current. So when V naught is equal to 0, so we will have the maximum value of current I naught is equal to 2V by omega ls into cos alpha. So the limits of the overlap period mu will be 0 to pi. So the 0 to pi. So for mu is equal to 0, we will have the maximum value of voltage, and for mu is equal to pi, we will have the maximum value of current. Right? So this will be the plot drawn between V naught and I naught, and this line will have the slope of minus omega ls divided by pi. And this can be generalized for impulse converter, that is falling output voltage due to overlap. So here the this will be the general expression, and for 2 pulse converter it will be omega ls into omega ls by I into I naught, and for 6 pulse converter or 3 phase it will be 3 omega ls by pi into I naught. So this will be the generalized expression. For single phase, so this m will be equal to 1, and for 3 phase it will be equal to 3. Right? Thank you.